October 24th, 1944, Palawan Passage, Philippines. The first light of dawn broke across the South China Sea as sailors aboard the Japanese destroyer Naganami approached something that would fundamentally alter what Imperial Japanese Army officers believed about their nation's industrial capability. There, run aground on Bombay Shoal, sat the American submarine USS Darter, her back broken on the reef. Her crew long evacuated to the rescue submarine USS Darter, but inside her conning tower, still mounted and operational, was a Browning M2 heavy machine gun. The Japanese boarding party carefully removed the weapon, 50 caliber, 12.7 millimeters, 84 pounds of American engineering. They handled it with a mixture of professional curiosity and something approaching reverence. This single weapon would soon travel to Tokyo, where it would be tested, measured, analyzed, and compared against the standard heavy machine gun of the Imperial Japanese Army, the Type 92. The results of those tests would be documented in reports that Imperial Army officers would read with growing dismay. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What those officers discovered was not a minor technical superiority. It was evidence of a manufacturing and design philosophy so fundamentally different from their own that it called into question everything they had been taught about Japanese martial superiority. The captured M2 Browning did not just outperform the Type 92 heavy machine gun. It exposed the uncomfortable truth that American weapons designers and manufacturers approached the problem of industrial warfare with a ruthlessness and practicality that Japanese tradition and limited resources simply could not match. This is the story of how one captured weapon became a mirror, reflecting back to Japanese military leadership, the harsh reality that the empire's heavy machine guns, designed to a different philosophy and constrained by different industrial limitations, were fundamentally outclassed. But to understand why this single weapon caused such consternation in Tokyo, we must first understand what Japanese officers had been taught to believe about their own weapons, and why the encounter with American industrial might would shatter those beliefs. The year was 1932. The place was the Kokura Army Arsenal in northern Kyushu, Japan. Engineer Kijiro Nambu, already famous for his namesake pistol, was putting the finishing touches on what would become the standard heavy machine gun of the Imperial Japanese Army for the next 14 years. The Type 92 heavy machine gun. The Type 92 represented Japanese military thinking at its most refined. It was based on the French Hotchkiss M1914, a proven design from the Great War, but modified to fire the new 7.7mm semi-rimmed cartridge. The Japanese had finally recognized, after decades with the underpowered 6.5mm Arisaka round, that they needed more stopping power on the modern battlefield. The 7.7mm was their answer, a round roughly equivalent to the British .303. The Type 92 weighed approximately 55 kilograms, about 121 pounds. Mounted on its distinctive tripod, which featured removable carrying poles, the entire weapon system could be transported by a crew of 3 to 6 men. The gun, fired from a closed bolt, was gas-operated and air-cooled. Its distinctive feature was a series of cooling fins around the barrel and gas piston, giving it a profile that Allied soldiers would learn to recognize across the islands of the Pacific. The gun was fed by metal strips, each holding 30 rounds. The strips had to be carefully inserted into the feed block, one after another, by the assistant gunner. This strip feeding system, inherited from the Hotchkiss design, was already obsolete by modern standards, but it was reliable enough if properly maintained. The practical rate of fire was about 450 rounds per minute. The practical range, the distance at which the gun could effectively suppress or destroy enemy positions, was about 800 meters. But the most unusual characteristic of the Type 92 was nearly invisible. An internal oil pump, mechanically activated by the bolt, dispensed a small amount of oil onto a brush. This brush then lubricated each cartridge as it was fed into the gun. In theory, this system ensured reliable extraction even with slightly undersized or dirty ammunition. In the pristine testing ranges of Kokura Arsenal, it worked beautifully. Japanese Army officers were taught that the Type 92 represented a perfect balance of firepower, mobility, and reliability. It was precision-machined, carefully assembled, and finished with a high-quality rust blue that spoke to Japanese craftsmanship. The gun was accurate, capable of being equipped with telescopic sights for precision fire at extended ranges. It was one of the few World War II machine guns commonly issued with advanced optical sights. A team could set up the gun, acquire a target at 600 or 700 meters, and place accurate suppressive fire with what American observers would later describe as remarkable precision. The training manuals emphasized this precision. Japanese heavy machine gun doctrine emphasized aimed fire, careful ammunition conservation, and the psychological effect of sustained, accurate fire on enemy morale. The Type 92 was not designed to spray bullets wildly in the hope of hitting something. It was designed to deliver carefully aimed rounds onto specific targets at specific distances. Allied soldiers who encountered the Type 92 in combat gave it a nickname that spoke to its distinctive characteristics. They called it the woodpecker. The relatively slow rate of fire, 450 rounds per minute, created a rhythmic, deliberate sound. Tack, 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 tack. Pause. Tack, tack, tack. Unlike the tearing canvas sound of faster-firing German or American machine guns, the Type 92 announced its presence with a measured cadence that echoed through jungles and across atolls. By 1941, when Japan launched its coordinated attacks across the Pacific, approximately 45,000 Type 92 heavy machine guns had been manufactured. They equipped every infantry battalion, defended every key position, and provided the backbone of Japanese defensive fire. In the opening campaigns of the war, in Malaya, in the Philippines, in the Dutch East Indies, the Type 92 performed exactly as designed. Japanese defensive positions, carefully prepared and well-sighted, stopped British, American, and Dutch attacks cold. At the Battle of Singapore, Type 92 machine guns decimated Australian and British infantry attempting to cross the causeway. At Bataan in the Philippines, American troops advancing through Japanese defensive positions encountered interlocking fields of fire from Type 92 guns that inflicted terrible casualties. The gun worked. It killed effectively. And Japanese officers had every reason to believe that it represented the pinnacle of heavy machine gun design. What they did not know, what they could not know, was that American weapons designers had approached the problem from an entirely different direction. While Japan had refined an existing design to achieve precision and reliability within their industrial constraints, America had created something fundamentally different. A weapon designed not for precision, but for overwhelming firepower. Not for careful ammunition conservation, but for sustained suppressive fire. Not for the skilled marksman, but for the average soldier who simply needed to fill a volume of space with lethal metal. The M2 Browning, designed by John Moses Browning and adopted by the United States military in the early 1930s, was a fundamentally different weapon. Where the Type 92 fired a 7.7mm cartridge roughly equivalent to the .303 British, the M2 fired a half-inch diameter projectile. The .50 caliber Browning machine gun cartridge properly designated the 12.7 by 99mm NATO round. The difference was not merely one of diameter. The .50 BMG cartridge fired a bullet weighing approximately 750 grains, compared to the Type 92's bullet weight of approximately 200 grains. The American round left the muzzle at 2,900 feet per second. The Japanese round managed about 2,400 feet per second. The energy delivered downrange was not 50% greater. It was not twice as great. The M2 Browning delivered approximately 3 times the muzzle energy of the Type 92. This was not a machine gun. This was a light cannon that happened to fire fully automatic. The M2 heavy barrel variant, the M2HB, which became standard during World War II, weighed 84 pounds. Not much heavier than the Type 92, but the ammunition was completely different. Where Japanese machine gun crews carried their ammunition in 30-round strips, carefully feeding each strip into the gun, American crews used disintegrating link belt-fed systems. 100-round belts, 200-round belts, even custom lengths feeding from enormous ammunition boxes. The practical rate of fire for the M2HB was between 450 and 575 rounds per minute, similar to the Type 92. But here the similarity ended. The M2 was designed for sustained fire. An experienced crew, with proper barrel management and adequate ammunition supply, could maintain fire almost indefinitely. The quick-change barrel system allowed a hot barrel to be swapped for a cool one in seconds. The gun could fire continuously, belt after belt, hour after hour, as long as ammunition and barrels held out. The effective range was 2,000 yards, not meters, yards. 1,830 meters, more than twice the practical range of the Type 92. And at that range, the half-inch projectile still carried enough energy to penetrate light armor, destroy vehicles, and create casualties. The M2 could reach out and touch targets that Japanese machine gunners could not even dream of engaging with aimed fire. But the most significant difference was philosophical. The M2 was not designed for precision-aimed fire. It was designed for area suppression. American doctrine did not train machine gunners to carefully place each round onto a specific target. American doctrine trained machine gunners to fill a beaten zone, an area of ground, with a continuous stream of half-inch projectiles. Anything in that zone died. It was not elegant. It was not economical. But it was devastatingly effective. American industrial capacity made this possible. Where Japan struggled to produce 45,000 Type 92 guns over the entire war, the United States would eventually produce over 3 million Browning machine guns of various types. Ammunition was equally abundant. By 1944, American factories were producing .50 caliber ammunition at a rate that Japanese planners simply could not comprehend. Tens of millions of rounds per month. Hundreds of millions of rounds per year. An American infantry company advancing across a Pacific island in late 1944 might have multiple M2 Brownings supporting its attack, each gun fed by thousands of rounds of belted ammunition. A Japanese infantry battalion defending that same island might have a dozen Type 92 guns, each carefully rationed to perhaps 2,000 rounds total, to be preserved and expended only when absolutely necessary. This was the industrial and philosophical gulf that existed when, on the morning of October 24, 1944, Japanese sailors climbed aboard USS Darter and unbolted an M2 Browning from its mount. They did not yet understand what they had captured, but they would learn. The Type 92 had been designed in an era when Japanese officers still believed that spirit and training could overcome material disadvantage. That Bushido, the warrior spirit, mattered more than industrial capacity. That a well-trained, disciplined soldier with an accurate weapon could defeat a less skilled enemy with a more powerful one. The entire Japanese military philosophy rested on this foundation. By late 1944, that foundation was cracking. Every island battle, every encounter with American forces brought the same lesson. American forces were not less skilled, they were not less brave, they were not inferior soldiers. They were simply equipped with fundamentally better weapons, in greater quantities, supported by an industrial base that seemed capable of producing infinite ammunition. Japanese infantry had learned to dread the sound of American machine gun fire, not the measured tack-tack-tack of the Type 92, but the sustained tearing roar of the M1919 Browning .30 caliber and the deeper, hammering thunder of the M2. The sound of metal rain that announced an American attack, a sound that could last for minutes or hours, ammunition seemingly inexhaustible. Japanese officers had begun to realize, privately and quietly, that their doctrine was obsolete. That precision, fire and ammunition conservation, virtues when resources were limited, were liabilities when facing an enemy with unlimited resources. That the Type 92, for all its accuracy and Japanese craftsmanship, was being outgunned by weapons designed to different principles. But understanding this abstractly, through combat reports and casualty statistics, was one thing. Having a captured American heavy machine gun in your hands, taking it apart, examining its construction, testing it against your own standard weapon, was something entirely different. The capture of the M2 from USS Darter would force Japanese officers to confront, directly and undeniably, exactly how far behind their weapons technology had fallen. The captured M2 was transported to Tokyo. It arrived at a Japanese Army Ordnance facility, probably the Technical Bureau of the Army General Staff, in late October or early November of 1944. A team of engineers and ordnance officers was assembled. A team of engineers and mindy too. This was not propaganda work. This was not an exercise in confirming Japanese superiority. This was technical intelligence, conducted by professionals who understood that accurate information about enemy capabilities was essential to military planning. The engineers approached their work with the same careful attention to detail that had characterized Japanese technical work throughout the war. They began with simple measurement and weighing. The M2 was heavier, but not dramatically so. 84 pounds versus the Type 92's 121 pounds, complete with its tripod. Both weapons required a crew to transport and operate effectively. The American weapon was slightly more compact, but both were recognizably heavy machine guns designed for similar tactical roles. Then they examined the manufacturing. Here, the first significant differences emerged. The M2's construction was robust, almost crude by Japanese standards. Tolerances were loose. Interchangeability of parts seemed to be a primary design consideration. Stamped parts were used wherever possible instead of precision-machined components. The finish was workmanlike, nothing more. No effort had been wasted on aesthetics. The Type 92, by contrast, showed evidence of hand-fitting and careful final finishing. The Japanese gun was a craftsman's weapon. The American gun was a factory product. Japanese engineers, trained to appreciate precision and fine craftsmanship, initially took this as confirmation of Japanese superiority. Look how crude the American weapon is. Look how much better our manufacturing standards are. Then they began the firing tests, and everything they thought they knew began to fall apart. The first test was basic function. Both weapons were loaded and fired at stationary targets at various ranges. Both guns performed reliably, but the sound, the physical sensation of firing, was completely different. The Type 92 barked with its familiar measured rhythm. The M2 roared. The recoil, even with the weapon firmly mounted, was noticeably heavier. Each shot from the M2 hit with visceral impact. Then came the penetration tests. Standard steel plate, the kind used in lightly armored vehicles. At 500 meters, the Type 92's 7.7mm rounds, using armor-piercing bullets, could penetrate approximately 10 millimeters of armor plate. Not impressive, but adequate for engaging unarmored or lightly protected targets. The M2's half-inch armor-piercing rounds punched through 22 millimeters of hardened steel at 100 meters. At 500 meters, they still penetrated 19 millimeters. The American gun was not merely more powerful, it was in a completely different class of weapon. The range tests produced even more disturbing results. Both guns were zeroed and fired at targets at progressively greater distances. The Type 92, with its excellent sights and accurate barrel, could place rounds on target out to 800 meters with reasonable precision. Beyond that distance, the 7.7mm bullets' remaining energy and stability made aimed fire ineffective. The M2 remained devastatingly accurate at 800 meters. At 1,000 meters, it still produced killing hits. At 1,500 meters, 1,800 meters, It continued to strike targets with enough force to cause casualties and damage equipment. The maximum effective range, the distance at which the weapon could still achieve its intended effects, was more than double that of the Type 92. But the test that truly demonstrated the gulf between the weapons was sustained fire. Both guns were set up, and crews were ordered to maintain continuous fire for as long as the weapons would permit. The Type 92 fed its 30-round strips one after another, maintained fire for perhaps 3 or 4 minutes before the build-up of carbon and oil residue, combined with the heat of sustained fire, began to affect reliability. The strip-feeding mechanism was sensitive. The oiler, so effective in clean conditions, accumulated dirt and carbon that eventually caused malfunctions. The crew had to stop, clear the gun, clean the action, and resume fire. The M2, fed from belted ammunition and equipped with a quick-change barrel, simply continued to fire. Belt after belt. 5 minutes, 10 minutes, 15 minutes. When the barrel grew hot, the crew changed it in seconds and resumed fire. The gun did not care about dirt. It did not care about carbon buildup. It was designed to function in the worst possible conditions, fed by marginally trained crews, and still deliver devastating firepower. 20 minutes of continuous fire. 30 minutes. The test only ended when the ordnance officers ran out of prepared belted ammunition. The engineers looked at each other. They looked at the smoking barrel of the M2, still mounted, still ready to fire if more ammunition had been available. They looked at the Type 92, sitting cold and partially disassembled for cleaning after only a fraction of the firing time. One of the senior officers present reportedly said what everyone in the room was thinking: "We cannot win against weapons like this." But the captured M2 revealed something even more troubling than simple technical superiority. It revealed that American weapons philosophy was fundamentally different from Japanese philosophy. The M2 was not designed to be the best heavy machine gun an engineer could create. It was designed to be the best heavy machine gun that could be mass-produced by the hundreds of thousands, operated by average soldiers with minimal training, maintained in field conditions with crude tools, and still deliver overwhelming firepower. The M2 prioritized reliability over precision. It prioritized ammunition capacity over conservation. It prioritized sustained fire over aimed fire. It prioritized manufacturing efficiency over craftsmanship. Every design choice in the M2 reflected American assumptions about industrial warfare, assumptions that Japan, with its limited resources and different cultural values, had never made. And the engineers knew something else. They knew that the Imperial Japanese Army had, in fact, attempted to copy American heavy machine gun design years before. In 1937, after examining examples of the Browning machine gun, Japanese engineers had created the Ho-103, a modified Browning-based design for aircraft use. The Ho-103 was chambered for a smaller 12.7mm round, the Italian Breda 12.7 by 81mm, rather than the American 12.7 by 99mm. The Ho-103 worked. It was lighter than the M2, fired faster than the M2, and equipped numerous Japanese Army Air Force fighters throughout the war. But it fired a less powerful cartridge, with less penetration, less range, less destructive effect. Japanese industry simply could not mass-produce the full-power American cartridge in sufficient quantities. The Ho-103 was a compromise, a good compromise, but still a compromise forced by industrial limitations. If Japanese industry could not even produce the .50 BMG cartridge in military useful quantities for their air force, how could they possibly equip their ground forces with an equivalent weapon? The answer was simple. They could not. The Type 92 was not inferior because Japanese engineers were incompetent. It was inferior because Japanese industry was operating under constraints that American industry did not face. The captured M2 demonstrated, with brutal clarity, that the material and industrial foundations of American military power were simply stronger than Japan's. That no amount of warrior spirit or tactical skill could compensate for this fundamental asymmetry. The written reports from these tests circulated among senior Japanese army officers in late 1944 and early 1945. The exact wording has not survived, as most Japanese military documents from this period were destroyed in the final weeks of the war. But we know from post-war interrogations that these reports existed, that they were read, and that they caused significant consternation among officers who had built their careers on the assumption of Japanese martial superiority. Some officers reportedly argued that the tests must have been flawed, that the M2 must have been an exceptional example, that surely not all American heavy machine guns could be this superior. But reports from the front lines confirmed what the engineers had found. Every captured American weapon, when tested, showed the same characteristics. Superior firepower, vastly greater ammunition supply. Design philosophy focused on overwhelming the enemy rather than outskilling them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The implications were devastating. Japanese military doctrine, Japanese training methods, Japanese tactical assumptions, all rested on the premise that superior skill and discipline could overcome material disadvantage. The samurai tradition emphasized mastery of weapons through endless practice. A skilled swordsman with a katana could defeat an unskilled opponent with any weapon. This philosophy had been transferred wholesale to modern military thinking. But the M2 Browning was not a weapon that required superior skill to operate. It was a weapon that required only basic competence. An American soldier with 2 weeks of training could mount an M2, feed it belted ammunition, and deliver sustained, suppressive fire that would keep an entire Japanese company pinned in their positions. The psychological effect alone was crushing. The knowledge that advancing into American machine gun fire meant walking into a steel storm that would not relent, would not run out of ammunition, would not pause to conserve precious rounds. Japanese soldiers had experienced this firsthand on every contested island and hilltop. At Tarawa in November 1943, Japanese defenders had fought with fanatical courage, but American naval gunfire and machine gun fire had simply obliterated defensive positions. At Saipan in June and July 1944, Japanese troops launched desperate banzai charges into interlocking fields of American machine gun fire. The charges failed, not because Japanese soldiers lacked courage, but because courage cannot deflect bullets, and the volume of American fire was simply too great. At Peleliu in September and October of 1944, even the most sophisticated Japanese defensive tactics, positions carefully prepared in coral caves and reinforced bunkers, could not withstand the combination of American flamethrowers, explosives, and sustained machine gun fire. The M2 could fire into cave mouths for hours, denying the defenders any chance to emerge or reposition. Japanese troops died in their positions, not from lack of will, but from lack of equivalent firepower. The capture of the M2 from USS Darter simply confirmed what frontline troops already knew. American weapons were not slightly better, they were fundamentally superior, and the reason for this superiority was not individual American genius. It was systematic American industrial capacity, the ability to design weapons for mass production, the ability to manufacture those weapons by the hundreds of thousands, the ability to produce ammunition in quantities that seemed, to Japanese observers, literally infinite. But the story of the captured M2 revealed something else, something that Japanese officers found even more troubling than simple material inferiority. It revealed that American weapons designers understood modern warfare better than their Japanese counterparts, that the philosophy behind American weapon design was more suited to 20th century industrial conflict than the philosophy behind Japanese weapon design. Consider the design priorities. The Type 92 prioritized accuracy, conservation of ammunition, and precise engagement of known targets. These were virtues in wars of limited resources, where every bullet counted, where ammunition supply was uncertain. The M2 prioritized sustained fire, overwhelming volume, and suppression of any potential threat in a wide area. These were virtues in wars of industrial production, where ammunition was unlimited, where the goal was not to carefully eliminate each enemy soldier, but to dominate the battlefield through sheer material superiority. The Japanese approach required skilled soldiers with extensive training. The American approach required adequate soldiers with basic training and unlimited support. In a long war of attrition, the American approach was demonstrably superior. You could train new soldiers more quickly. You could accept higher casualty rates because replacements were available. You could win through material exhaustion of the enemy, even if individual engagements were tactically stalemated. Japanese officers who read the technical reports on the captured M2 understood these implications. They understood that Japan's entire military philosophy was obsolete, that the assumptions underlying their training, their tactics, their weapons procurement were based on a model of warfare that no longer applied. But understanding this and doing anything about it were two different things. By late 1944, Japan's industrial situation was desperate. American submarines had devastated the merchant fleet. Raw materials from the southern resource area, the Dutch East Indies and Malaya, could no longer reliably reach Japan. Factories were being targeted by B-29 bombers flying from the Marianas. Production of existing weapons was barely adequate to replace combat losses. There was no possibility of redesigning and retooling for entirely new weapon systems. Even if Japanese industry could have produced an equivalent to the M2 Browning, even if engineers could have designed a 12.7mm machine gun firing the full-power American cartridge, there was no industrial capacity to manufacture it in useful quantities. The aluminum alloys, the specialized steels, the precision manufacturing equipment, the trained workers, none of these existed in sufficient quantity to make a difference, and the ammunition would have been an even greater problem. The .50 BMG cartridge required substantial quantities of brass, lead, steel, and propellant. Japanese industry was already struggling to produce adequate quantities of 7.7mm ammunition for existing weapons. Scaling up to produce 12.7mm ammunition in the quantities American doctrine required, millions of rounds per month, was simply impossible given Japan's resource situation. So Japanese officers faced a cruel choice. Continue using weapons they now knew to be inferior, because those were the only weapons available. Continue training tactics that emphasized spirit and courage for material superiority, because those were the only tactics that offered any hope of success. Continue fighting a war they increasingly understood they could not win, because surrender was unthinkable. The psychological impact on officers who understood the situation cannot be overstated. These were men who had devoted their lives to the military profession. Men who had studied warfare, had led soldiers, had believed absolutely in the superiority of Japanese martial spirit. The captured M2 forced them to confront the reality that material factors completely outside their control, had determined the outcome of the war long before the first shot was fired. Some responded with denial. The weapon must be exceptional. American soldiers must not be able to use it effectively. Quantity cannot overcome quality. These reassurances became increasingly hollow as reports from the front continued to tell the same story. American firepower was overwhelming Japanese defensive positions everywhere. Others responded with despair. If American material superiority was this great, if Japanese weapons were this outclassed, what hope was there? The war was lost. Continuing to fight was merely sacrificing more Japanese lives for no purpose. But this thought, however logical, could not be spoken aloud. Defeatism in wartime Japan was not merely career-ending, it could be fatal. A few responded with cold analysis. If material factors determine outcomes, then Japan's strategy must focus on those factors. Interdict American supply lines, target ammunition dumps and logistics bases, force battles in conditions where American firepower advantage is minimized, close-quarters combat in caves and fortifications where heavy machine guns cannot be brought to bear effectively. Make the war so costly that America loses the will to continue. This last approach, a strategy of attrition and exhaustion, became the de facto Japanese strategy in the final year of the war. The island defenses at Iwo Jima and Okinawa were designed explicitly to minimize American firepower advantages. Japanese troops dug elaborate tunnel systems, emerged only at night or in close combat, and forced American forces to clear positions one by one in brutal close-quarters fighting. It did not work. American forces developed tactics to counter this approach: flamethrowers, satchel charges, and sealed cave mouths with explosives. And when close combat was unavoidable, American forces simply brought overwhelming numbers. The M2 Browning might not be able to fire directly into cave systems, but it could interdict approaches, suppress Japanese counterattacks, and provide covering fire while assault teams maneuvered. At Iwo Jima in February and March of 1945, Japanese defenders held out for 36 days, inflicting terrible casualties on American Marines. But the outcome was never in doubt. American material superiority, including the ubiquitous presence of M2 Brownings, providing supporting fire, eventually ground down the defense. Of the 21,000 Japanese defenders, only about 200 were captured alive. The rest died in place. Courage and determination without equivalent firepower. At Okinawa from April through June of 1945, the largest land battle of the Pacific War, Japanese forces fought with remarkable tactical skill, using terrain and prepared positions to extract maximum casualties from the American advance. But again, the outcome was determined by material factors. American forces had more men, more weapons, more ammunition, more support. The Japanese 32nd Army was annihilated, over 100,000 Japanese soldiers dead. The captured M2 Browning had become, in a sense, a symbol, not just of American technical superiority, but of the entire industrial and philosophical gulf between the two nations. An American weapon designed for mass production, operated by adequately trained soldiers, supported by limitless ammunition, versus Japanese weapons designed for skilled use, operated by highly trained soldiers, supported by carefully rationed ammunition. In a war of industrial attrition, this was not a fair fight. It had never been a fair fight. The Japanese officers who examined the captured M2 in late 1944 understood this. They understood that courage and skill, while necessary, were not sufficient. That the war would be won by the side that could produce more weapons, more ammunition, more everything, and use them effectively. The irony is that Japanese engineers had recognized American industrial philosophy years before. The Ho-103 aircraft machine gun, developed in the late 1930s, was explicitly based on the Browning design. Japanese engineers understood that the Browning action was reliable, simple, and suited for mass production. They had attempted to adapt this design to Japanese industrial capabilities and ammunition availability. But aircraft weapons and ground weapons face different constraints. An aircraft-mounted gun can be lighter because the aircraft provides structural support and cooling airflow. Ammunition weight is critical in aircraft, so smaller cartridges are acceptable. Ground-based heavy machine guns need maximum range and penetration, which requires maximum cartridge power. And ground crews can carry much more ammunition, so belt-feeding large quantities becomes essential. The Japanese Army had the Ho-103 as proof that Browning's design philosophy worked. They could have attempted to develop a ground-based heavy machine gun using similar principles. But to do so effectively would have required abandoning the 7.7mm cartridge and developing a truly powerful heavy machine gun cartridge equivalent to the .50 BMG. This decision would have needed to be made in the mid-1930s, when Japanese industrial planning was still optimistic and resources were less constrained. It was not made, whether through institutional inertia, confidence in existing designs, or realistic assessment of industrial limitations. Japanese military planners decided to refine existing designs rather than develop entirely new weapons. The Type 92 remained the standard heavy machine gun, and by the time American forces demonstrated the superiority of their approach, it was far too late to change course. There is a broader lesson here about military procurement and weapons development. The best weapon is not necessarily the most elegant or precise. The best weapon is the one that can be produced in adequate quantities, operated by available personnel, and supported logistically in actual combat conditions. A perfect weapon that cannot be mass-produced is less valuable than a good weapon that can be manufactured by the millions. The M2 Browning was not perfect. It was heavy. It required substantial ammunition supply. The headspace adjustment, the spacing between the bolt face and barrel, was notoriously difficult to set correctly and could cause malfunctions or injury if improperly adjusted. In cold conditions, the gun could be difficult to operate. In sandy conditions, it required constant maintenance, but none of these drawbacks mattered strategically. Because American industry produced so many M2s and so much ammunition that crews could train extensively, replacement weapons were available if one failed. Maintenance parts were abundant. The weaknesses of the design were overcome by the strengths of the industrial system that produced it. The Type 92, by contrast, was in many ways a superior precision instrument, more accurate, better suited for skilled employment, lighter and more mobile when properly crewed. But Japanese industry could not produce enough of them, could not provide enough ammunition, could not support them logistically under combat conditions. The strengths of the design were undermined by the weaknesses of the industrial system that produced it. This is the tragedy that Japanese officers confronted when they examined the captured M2. They were not looking at a better machine gun. They were looking at evidence of a better military-industrial system, a system that integrated design, manufacturing, logistics, training, and tactical employment into a coherent whole, a system that Japan, despite considerable technical skill and industrial capacity, simply could not match. The final months of the war saw Japanese industry in complete collapse. American bombing had destroyed key factories, fuel shortages had shut down others. The remaining operational plants struggled to produce even basic items. New Type 92 machine guns were still being manufactured in small numbers, but quality control had deteriorated significantly. Late war production guns were rougher, less reliable, more prone to malfunction. American M2 production, by contrast, continued at full capacity right up to the surrender. The last M2s, manufactured in August of 1945, were identical in quality to those produced in 1941. American industry had achieved true mass production, where individual items were fungible, interchangeable, and consistent. This was the industrial philosophy that Japanese industry, despite impressive achievements in specific areas like optics and precision mechanisms, had never fully mastered for military production. After the war ended in August 1945, American technical intelligence teams fanned out across Japan, examining captured Japanese weapons and facilities. They found the reverse-engineered M2s, the attempts to understand American design philosophy, the reports on comparative testing. American analysts were impressed by the thoroughness of Japanese technical intelligence work. The reports on the captured M2 were professional and accurate, but American analysts also noted the futility of the effort. Even if Japanese engineers had fully understood American weapons design, even if they had perfect knowledge of how to replicate American capabilities, Japanese industry lacked the resources to implement that knowledge. The war had been lost on production lines in Detroit and Pittsburgh, long before it was lost on battlefields in the Pacific. The Type 92 heavy machine guns, thousands of them, were collected by occupation forces. Many were destroyed. Some were retained for museums and technical evaluation. A few found their way into the hands of other military forces in Asia during the turbulent post-war years. Communist forces in China used captured Type 92s during the Chinese Civil War. North Korean forces used them during the opening phases of the Korean War in 1950. American soldiers who encountered Type 92s in Korea in 1950 found them to be effective weapons in the hands of well-trained crews employing good tactics. But they also noted that North Korean and Chinese forces were desperately short of ammunition, that the guns often malfunctioned due to poor maintenance, and that American forces still enjoyed overwhelming firepower superiority. The M2 Browning, meanwhile, went on to become one of the most successful weapons designs in history. It served in Korea, it served in Vietnam, it served in every American conflict through the Cold War and beyond. With minor modifications, the same basic design that Japanese engineers examined in 1944 is still in frontline service today, more than 80 years after its initial adoption. Production has exceeded 3 million units. It has been used by virtually every nation aligned with or supplied by the United States. This longevity speaks to the fundamental soundness of the design philosophy. The M2 was not optimized for any specific conflict. It was optimized for industrial production and reliable function across a wide range of conditions. This made it adaptable, maintainable, and effective across decades of changing military requirements. A weapon designed for mass production in the 1930s proved still relevant in the 21st century. The Type 92, by contrast, represents a dead end in machine gun development. Its design philosophy, emphasizing precision and skilled operation over raw firepower and ease of use, was shown to be inadequate for modern industrial warfare. No military force after World War II adopted similar designs. The trend in post-war machine gun development was consistently toward higher-powered cartridges, belt-feed systems, quick-change barrels, and designs optimized for sustained fire rather than aimed precision. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe. The captured M2 Browning taught Japanese officers a lesson they already knew but had not wanted to acknowledge: that in modern industrial warfare, material factors dominate, that weapons must be designed for the industrial and logistical system that will produce and support them, that tactical skill and individual courage, while necessary, are not sufficient against an enemy with superior material resources. This lesson has broader implications beyond World War II. Every military must design weapons appropriate to its industrial capacity, its logistical capabilities, and its strategic situation. Copying enemy designs without the supporting infrastructure to produce and employ them effectively is worse than useless. It diverts resources from designs you can actually implement. Japan's experience with the M2 Browning illustrates this principle perfectly. Japanese engineers could examine the weapon, understand its construction, recognize its superiority, and still be unable to do anything useful with that knowledge, because the problem was not understanding. The problem was industrial capacity and strategic resources. And by 1944, when the captured M2 arrived in Tokyo for analysis, those problems were unsolvable. The officers who read the reports on the captured M2 knew this. They knew the war was lost. They knew that Japanese weapons, Japanese tactics, and Japanese industrial capacity were inadequate to defeat an enemy with America's resources. But they also knew that surrender was not an option their culture or government would accept. So they continued to fight, using inferior weapons, in battles they could not win, until the atomic bombs and Soviet invasion finally provided a face-saving excuse for the emperor to end the war. The captured M2 Browning sits now, or sat then, as a silent witness to the futility of that final year of fighting. A weapon that demonstrated everything Japanese officers feared about American material superiority. A weapon that showed, with brutal mechanical clarity, that the outcome of the Pacific War had never really been in doubt. Not because American soldiers were superior to Japanese soldiers, but because American industrial capacity was overwhelming and American weapons design philosophy was better adapted to the realities of 20th century industrial warfare. The Type 92 was a good weapon, well designed for its intended purpose, manufactured to high standards by skilled workers. It was not the problem. Japanese industrial capacity, resource availability, and strategic situation were the problems. The Type 92 was simply the tangible manifestation of those problems, a weapon constrained by realities that no amount of engineering skill could overcome. The M2 Browning was a good weapon, well designed for mass production, optimized for reliability and sustained fire. It was not inherently superior in all aspects, but it was superior in the aspects that mattered for industrial warfare, and it was backed by an industrial system capable of producing it in quantities and ammunition in quantities that made tactical superiority achievable regardless of individual skill differences. This is the story that the captured M2 tells, not a story of individual genius or technical breakthrough, but a story of systemic differences in industrial philosophy and military procurement. A story of how design decisions made in the 1920s and 30s about what kind of military force to build and how to equip it determined outcomes on battlefields in the 1940s. The Japanese officers who tested the captured M2 understood this story. They understood that they were not defeated by better soldiers or better tactics. They were defeated by a better military-industrial system, a system that could design, produce, and employ weapons more effectively than their own. This understanding, this recognition of systemic failure rather than individual failure, was perhaps more bitter than any battlefield defeat. Because a battlefield defeat can be avenged, a tactical mistake can be corrected, but a systemic disadvantage in industrial capacity and design philosophy cannot be overcome without fundamental transformation of society and economy. And by late 1944, such transformation was impossible. Japan could only fight on with the industrial capacity and weapons design philosophy it had, however inadequate, until the war ground to its inevitable conclusion. The captured M2 Browning was sent to Tokyo for evaluation. It was tested, measured, analyzed, and compared against Japanese weapons. The reports were written and distributed. Officers read them and understood their implications. And then, because there was nothing else to be done, the war continued. The weapon itself may still exist somewhere in a museum or private collection. Or it may have been destroyed in the final weeks of the war when Japanese military authorities burned documents and destroyed equipment to prevent it from falling into American hands. We do not know its ultimate fate, but the lesson it taught remains relevant. In warfare, as in so many human endeavors, success comes, not from individual moments of brilliance, but from systematic advantage. From industrial capacity, from design philosophy, from logistical support, from training systems, from all the unglamorous background factors that enable frontline forces to function effectively, the M2 Browning was not a miracle weapon. It was the logical product of a military-industrial system that understood how to win industrial wars. The Type 92 was not a failure. It was the logical product of a military-industrial system operating under severe constraints. The captured weapon simply made these systemic differences visible to Japanese officers who had, until that moment, convinced themselves that spirit and skill could overcome material disadvantage. They learned otherwise. They learned it too late to change the outcome, but they learned it thoroughly. And in the post-war years, when Japan rebuilt its military forces under American supervision, the lessons of weapons like the captured M2 were not forgotten. Japanese self-defense forces adopted American-style weapons, American training methods, and American military doctrine. Because the experience of World War II had demonstrated, conclusively and brutally, which approach to military organization and weapons procurement actually worked. The story of the captured M2 Browning is not really about one weapon. It is about the collision between two military philosophies, two industrial systems, two approaches to warfare, and about how that collision produced a lesson that Japanese officers learned at tremendous cost. That in modern war, material factors matter more than anyone wants to admit. That the best trained soldiers with inferior weapons will lose to adequately trained soldiers with superior weapons. And that weapons design must be integrated with industrial capacity, not divorced from it. This lesson, purchased with the blood of hundreds of thousands of Japanese soldiers who fought bravely with inadequate weapons, remains relevant today. Military forces around the world still struggle with the tension between designing the best possible weapon and designing a weapon that can actually be produced, supplied, and maintained under real-world constraints. The captured M2 Browning stands as a reminder that the latter approach, however unglamorous, is the one that wins wars.